So let us start our lecture. So in the previous lecture we have seen a set of relations called Green's relations, L, R and H. Then we also defined D and J relation. ओके वो रिलेशंस हमने सारी डिफाइन की है ना, तो उस पर हमने एक प्रपोजिशन भी की है, दिस एल एंड आर दे कम्यूट, और वहाँ से हमने ये फॉलो किया इनका जो जॉइन होगा दैट्स एल कंपोजिशन आर, वो भी हमने चेक किया था. अब एक्सरसाइज इस पर है जो मैंने इसमें शायद बताया था आपको. प्रूव दैट ऑन अ ग्रुप जी ऑल द रिलेशंस आर इक्वल एंड दे आर एक्चुअली यूनिवर्सल रिलेशंस. If G is a group, if G is a group, then show that these relations they are all equal. This H it's equal to L, which is equal to R, and this thing it's equal to D, and that's equal to G. One more exercise. If S a commutative semigroup, के लिए ये रिजल्ट है. If S a commutative semigroup, if S is a commutative semigroup, then show that all the relations are equal, but they are not equal to in this case they are all equal to G cross G. Okay, in the first exercise, and in this case they are all equal, but they are not equal to G cross G. Okay, this H it's equal to L, is equal to R, is equal to D, and this is equal to G. Now we will characterize another class of semigroups where this D is equal to G. D relation is equal to G. So in general, we have the inclusion H is substop L, L is substop D, D is substop J in general. Okay, but for a certain class of semigroups, we have the equality D is equal to G, not the general equality, all the equalities, but at least for these two relations, D relation and G relation, these two are equal for certain class of semigroups. So let's first define that class of semigroups. Let's have a definition here. A semigroup S is said to be periodic. If every element, or each element of S has a finite order. अब यहाँ से एक रिमार्क आप निकाल सकते हो. रिमार्क, अपना कैमरा सब लोग ऑन करें. We have a remark from this definition and the theorem, one of the theorem that we have done in the chapter 1, unit 1, for finite monogenic semigroups. Okay, so if S is a periodic semigroup, if S is a periodic semigroup and A belongs to S, okay, then there exists a positive integer. Say k, such that A power k is an idempotent idempotent. That means every element of S power, there is a power of that element which is an idempotent. So you can do this since A is a finite order, therefore we have finite monogenic semigroup generated by A. Let's suppose that that's your U, it's a subsemigroup of S, and this thing is a finite monogenic semigroup. And we know that if we have a finite monogenic semigroup, then this semigroup has a subgroup that we denote by K. Okay, ये हमने किया है, which is your U, that sub stuff S. So this K is a subgroup. अब इसकी जो identity होगी इस K subgroup की, that is an idempotent of U and hence an idempotent of S. तो जो भी पीरियाडिक सेमीग्रुप होगा उसका जो भी एलिमेंट आप लीजिए, इसका कोई ना कोई पावर एग्जिस्ट होगा उस एलिमेंट का. ओके, every element has a power such that the resultant element will be an idempotent of a semigroup S. हर किसी एलिमेंट का कोई पावर एग्जिस्ट होगा. पावर ऑफ every element is an idempotent. Some power of every element is an idempotent. Some power, कोई पावर एग्जिस्ट होगा, कोई इंटीजर k एग्जिस्ट होगा such that a power k is an idempotent. तो रीजन ये है इसका क्योंकि ये फाइनाइट मोनोजेनिक सेमीग्रुप होगा, बिकॉज ए इज अ फाइनाइट ऑर्डर. तो अगर ये फाइनाइट मोनोजेनिक सेमीग्रुप होगा, ये सब सेमीग्रुप एस का है, तो इस फाइनाइट मोनोजेनिक सेमीग्रुप का कोई सबग्रुप एग्जिस्ट होगा दैट वी हैव डिनोटेड बाय के ए. इस सबग्रुप के ए के पास आइडेंटिटी होगी, वो इन जनरल यू और एस की आइडेंटिटी तो नहीं होगी, मगर वो के ए की आइडेंटिटी. अगर वो के ए की आइडेंटिटी है तो उसमें ई स्क्वायर ई के बराबर है. अगर वो ई है तो के ए का एलिमेंट है, ये यू का भी एलिमेंट है, ये एस का भी एलिमेंट है. सो दैट देयर इज एन एलिमेंट ई इन एस सच दैट ई स्क्वायर इज इक्वल टू ई. सो यू कैन डू दिस. है तो मैंने पूरा एक्सप्लेन कर दिया आपको, अब आपको सिर्फ लिखना है ये. Now we have a following proposition. Now we have the following proposition. If S is a periodic semigroup, okay? If S is a periodic semigroup, if S is a periodic semigroup, then D relation is equal to G. D is equal to G. In general, D is substub G, okay? In general. But you had to prove that D is equal to G for every periodic semigroup S. Proof. Since this D is always substub J, so we only show that therefore it suffices to show that this J relation, it is subset of D relation. So we have to show that J is subset of D. Okay, J is subset of D. So let's take a pair in J. J is a relation. Let's take a pair. Say the pair is AB. Let's take a pair in J. What's J? What's J is? J की definition क्या है? What's J?
There will exist a X, Y.
J relation, it is there exists, yes, you are right, there exists.
X, Y, U,
Okay.
V.
So then there exists x, y, u, v
U
in S1
belongs to S1
such that
such that X, A, Y is equal to B
x, a, y is equal to b
and U, V, V is equal to A.
and u, v, v is equal to e. इसका नाम आप 1 रख दीजिए. ओके, नेम इट 1. ओके, इट्स हियर, यस, इट्स u, v, v. नेम इट 1. So आपको प्रूव करना है. We show that AB is in G. We show that AB belongs to D. Okay, AB belongs to D. What's D? Yes. What's this relation D? It's yes, it is a join of L and R. इसकी definition है ना, and that's equal to the composition because these relations commute. It's L composition R. तो हम प्रूव करेंगे A B D में है, A B D में है, D is L composition R. So that's we show that this, that is there exists C in S such that AC belongs to L, यह हमें प्रूव करना है, and CB belongs to R, इसको प्रूव करना है. हमें एक C चाहिए with this condition, AC belongs to L and CB belongs to R. So from 1 we have, from 1, let's see this one. From 1 we have A, that's equal to U, B, V, that's equal to U. What's B? B is equal to X, A, Y, X, A, Y, V, and this is equal to U, X, A. What's A? Is again U, B, V, then Y, V, then again this is equal to U, X, U, then B. What's B again? B is again X, A, Y, then it's V, Y, V. Okay, now you again apply this A, or you can say it's ux square A, so it's ux whole square, then A, yv square. Okay, it's equal to ux square A, then vy. Yes, is it Vy or Yv? It's Yv, okay?
Vy.
I think it should be Yv. Yv. Yv square, okay? Yv. Vy है कि Yv है? One minute, just a minute. It's yv. Okay, it's yv. It's yv.
Y.
So in general, for every n greater or equal to 1, we have a is equal to ux power n, because you can repeatedly apply equation 1, so you will get this ux power n a yv power n. Similarly, we have the following relation. Similarly, for all n greater or equal to 1, this b, it's equal to xu power n, then b, then b, then it's vy. Okay, here it's vy. So this is second and this one is third. So this element xu and ux. Okay, let's see this ux. It is an element of S, and S is a periodic semigroup, so we must have some positive integer m, such that ux power m is an idempotent of S. Since our S is periodic semigroup, S is periodic, and this ux, it belongs to S, so there exists a positive integer n, positive integer m, such that ux power m is an idempotent of S. Is an idempotent of S. This is an idempotent of S. Now actually we want to define C. Let's define now C. Okay. Let's define C now. Okay, define C by C is equal to XA. तो ये हम डिफाइन करेंगे क्योंकि ये S का एलिमेंट है, X भी S का है, A भी S का है, तो प्रोडक्ट S का है. अब यहाँ C इक्वल टू एक्स ए, इसमें तो आपके पास लेफ्ट साइड में एलिमेंट X आ गया. अब आपको प्रूव करना है AC बिलोंग्स टू L. AC ओके, उसके लिए आपके पास दो इक्वेशन होनी चाहिए. AC बिलोंग्स टू L, उसके लिए दो एलिमेंट्स X तो होने चाहिए A और C के लिए, सच दैट X और Y, सच दैट XA इक्वल टू C एंड YC इज इक्वल टू A. ये आपको चाहिए. C इक्वल टू X है, तो ये तो डेफिनेशन से ही है, जो आपने जैसे आपने C को डिफाइन किया, ये वहाँ से आपके पास गिवन है. अब आपको एक्चुअली A चाहिए. A शुड बी इक्वल टू एलिमेंट ऑफ S1 टाइम्स C, दिस A. So let's calculate A now. Let's find A. Now A is equal to, what's A? A is equal to ux power m. Okay, because it's true for every n, in particular for n equal to m in second. Okay, then we have yv power m by second. Okay, and taking this n equal to m. This thing it's equal to, now this ux power m is an idempotent, so we can write this as ux power m because it is an idempotent. Then we have a yv power m because ux power m is an idempotent, is an idempotent. Okay. We want to show that A equal to element of this times C. What's your C? C is equal to XA. So on this side we must have XA. Okay, XA, we must have XA. This thing is equal to X. Okay, this thing is equal to A actually. By, let's name it fourth. By definition of C, it's equal to C. So it's not equal to A. It's not equal to A. We want this A should be equal to some element times C. So this thing is C. Okay, this is C. It's fine. It is C. So I think we have done it. Okay, this is equal to ux power m, then C. Now this should be element of y times C. This should be element of y times C. So it's not C, it's actually A here. Sorry, this is A. Ux this thing. Okay, this thing is equal to A. This is A. Okay, again by second, it's by second, and in second n is equal to m. I want XA here, so that I will write it in the form of YC. So I will expand this. It's ux power m minus 1. This I can done because m is a positive integer. Then ux, then e. Then this is equal to, so let's this is your element y. It's y xa, where y is equal to that ux power m minus 1, then u, and this is equal to y. What's xa? Xa is c, where y is equal to ux power m minus 1, then u, and this c, it's actually from by fourth. Okay, this is by fourth. xa is equal to c. आप दो स्टेप्स लिख सकते हो. पहले yxa को आप लिखिए where y is equal to ux power m minus 1 u. The next step you will write yc और उसको आप लिखिए by 4. So thus we have c equal to xa and a equal to yc. So that means this ac, they are L related. AC belongs to L. So therefore we have this xa, it's equal to c, and yc is equal to b, where x and y, they are in S. So therefore this implies a c belongs to L. Now we show that this CB belongs to R. CB, C तो हमने already define किया है. Next we show that CB belongs to R. CB belongs to R. So we have अब right side elements आने चाहिए. We have, let's what's this C. Okay, हमने वहाँ पर जो एलिमेंट हमने y लिखा ना, y मत लिखिए क्योंकि y हमने ऑलरेडी चूज किया है. अब y की जगह पर लिखिए y डैश, जो ना हमने प्रीवियस इक्वेशन लिखी है, जहाँ पर हमने वो ux पावर m minus 1 u को लिखा y के बराबर. y आप मत लिखना, y की जगह पर आप y डैश लिखना या z लिखना. ओके, z या y डैश. आपको समझ आ रहा है मैं क्या कह रहा हूँ? क्योंकि y ऑलरेडी आपके पास है, उससे कंफ्यूजन क्रिएट होगा. वो y नहीं है वो एलिमेंट, उसको आप z से डिनोट कीजिए या y डैश y प्राइम से डिनोट कीजिए. ओके, So we have this cy. Let's find cy. We will see that cy is equal to b. Cy. This is c and y. Okay. Which is equal to what? C. C is equal to xa. Xay by 4. Now this xay, it's equal to b. So thus this is by first. So cy is equal to b. अब हमें b के साथ कोई एलिमेंट चाहिए. b times z is equal to c. तो वो z एक्चुअली हमें जो we have to define that z. वो एलिमेंट कौन सा होगा? So again since this yv again this yv, it belongs to S, and S is a periodic semigroup, so there exists some positive integer, let's write that as k, such that this yv power k is an idempotent, isn't?
अरे ऊपर yc equal to b कैसे है?
Yes, cy is equal to b. c किसके बस? ये आपने ऑलरेडी डिफाइन किया ना. c is equal to xe.
सर ऊपर जहाँ पे आपने लिखा therefore x is equal to c and yc is equal to b.
हाँ, ये हमने पहले लिखा ना. c को हमने डिफाइन ही किया ना. c को हमने डिफाइन किया xa, और yc की जगह पर मैंने आपको कहा आप y मत लिखिए वहाँ पर. y आप z लिख दीजिए या y डैश लिख दीजिए. ओके, यू वुड राइट हियर zc इक्वल टू b. तो ये तो जो आपने इससे पहले जो पेज लिखा ना वहाँ पर आपको है ये जस्ट दिस प्रीवियस इक्वेशन, प्रीसीडिंग इक्वेशन वी सी, जहाँ पर मैंने yc लिखा ना, yc इक्वल टू b, y की जगह पर आप z लिख दीजिए. zc इज इक्वल टू b. ओके, दिस इज हियर z.
सर हमने किया था ये यहाँ पे फिर a था कि b? जहाँ पे हमने लिखा now a is equal to, वही हमें आया.
हाँ, वहाँ से a आपको आ गया. a yes a. ओके, so sorry it's c here. हमें c चाहिए एक्चुअली. it's c, you are right. it's zc इक्वल टू a आना चाहिए ना. zc इक्वल टू a आ गया आपको वहाँ पर. a yes, you are right, it's a here. हमें a और c रिलेटेड चाहिए ना. a और c. b अभी हमने नहीं लिया, b हम इसमें अब लेंगे. थैंक यू, आपने इसको करेक्ट कर दिया यहाँ पर. इट्स zc इक्वल टू a. ओके, zc इक्वल टू a. So there exists some positive integer k such that yv power k is an idempotent because S is a periodic semigroup. So let's use this idempotent now. We have c equal to, now actually हमें क्या चाहिए? cy तो b के बराबर आ गया. अब हमें c चाहिए equal to b times some element. अब हम c से स्टार्ट करेंगे. Now what c? Now c by definition it's equal to xa by 4, जहाँ पर हमने इसको डिफाइन किया. Now again what's a? a is equal to this ux power any integer. Let's choose the integer k plus 1 here. a, then yv power k plus 1 by second I think, and choosing n equal to k plus by second or third. या आप देख लीजिए. I think it's second. Okay, by second n equal to k plus 1. This is equal to if you expand this now k plus 1 times. Okay, and you will see this is equal to xu power k plus 1 then x. Okay, suppose मैं उसको यहाँ पर explain करूँगा. Suppose you had this u x then ux power say cube. Okay, you can write this as x then ux, you know, just club these two, xu. So it's equal to xu power 3 then x. आपको समझ आ रहा है ये? तो आप इसको एक्सपेंड भी कर सकते, यू कैन इजली डू दिस. सो दिस इज इक्वल टू एक्स यू पावर के प्लस 1 देन एक्स. Just you can see this one for q for x ux power 3. Okay, yeah, so then we have okay, it's now ux, okay, xu now. This is equal to x u power k plus 1. Okay, here it's yv power k plus 1, k plus 1, and this is here a, sorry, ax. Let's write it again here. It's a, it's x first, then a, then now you can expand this. It's yv को आप बाहर निकालिए, yv, then it's yv power k. Okay, so what's this xay? It's actually b. This xay, it's b. This is b. Then we have v and yv power k. B equal to xay, it's by third. It's by 1, sorry. By 1. Again, this yv is an idempotent, so I can write it as yv power 2k. This is equal to xa power k plus 1, then b, then v, then yv power 2k.
For xu.
bv. Okay, this is 1 minute. Let's see it again. It's yv power k, yv power k plus 1. Okay, yv power k. This is yv. Then it will be it's first yv. Okay, yv. Then it will be vy now. It should be now vy. Yv. Vy power k then v. Okay, so vy power k then v. Okay, it's vy is actually idempotent. Yes, vy, is it vy or yv idempotent? yv idempotent है कि vy?
सर वहाँ पे हमने yv लिखा था, हमने vy लिखा.
vy हमने idempotent लिखा है,
yv लिखा सर.
yv idempotent है. Okay, yv is an idempotent, so it's yv. यहाँ पर vy
सर वहाँ पे vy होना चाहिए.
आइडेम्पोटेंट vy होना चाहिए. एग्जैक्टली, आप vy ही आइडेम्पोटेंट लिख दीजिए वहाँ पर. ओके, vy आप आइडेम्पोटेंट लिख दीजिए. vy पावर k इज एन आइडेम्पोटेंट. ओके, vy. सो दिस इज हियर, कैन चेंज इट हियर. इट्स इक्वल टू, it's first it's v. Okay, then okay, it's yv. It's okay, y को आपने बाहर निकाला. Now it will start with v. Okay, तो ये स्टेप भी आप चेंज कीजिए. इट इज ओके ओके ओके, यू आर राइट. हम इसको ऐसे कर सकते हैं. y को हमने इसके साथ बाहर निकाला, ए वाई के साथ. अब ये v से स्टार्ट हो गया, वी वाई पावर k, और एक y यहाँ पर आ जाएगा. दिस इज वी वाई पावर k and this is y here. Now this vy power k is vy power, okay, this is, so this is b, then vy power 2k, vy power 2k and y, because vy power 2k is an idempotent, vy power 2k is an idempotent. ओके यहाँ पर जो लास्ट एलिमेंट है ना, इट्स नॉट, ये वी है एक्चुअली. ओके देयर इज अ मिस्टेक, इट्स वी हियर नॉट वाई, इट्स वी हियर, इट्स वी हियर. ओके ये एंड वी पर हो रहा है ना, इट्स वी वी वी, it's v here. Yes. Now we can write it as x a power k plus 1, then we have b, then we can write this as vy power k plus 1 and vy power k minus 1. You can add these two things, you will see it will be vy power 2k, then we have v here. Now this one, this is equal to b by 4 by third, this is your b, it's k plus 1 here. So it's equal to b times vy power k minus 1 v, it's b vy power k minus 1 v. So that's your what's this? This is c actually. C is equal to this. So c it's element of s, then it's b and then element of s. Element of s is on right side. So thus we have what's we have this b. We have cy. Sorry, we have cy. We have cy is equal to b. And b times this element vy power k minus 1 v is equal to c. So therefore c and b they are all related. So thus we have this ab, they are L composition are related, that's equal to d. So therefore our d, therefore our J is subset of D, and hence this D it's equal to G.